I'm going to review for you the transfusion reaction workup. We're going to go through step by step and talk about the different steps and what's going on and why we're doing each of the steps along the way. So we're going to follow the board. First off, we're going to start up here, what you're given. When the nurses come back from the floor, they're going to give you the unit. They're going to give you the unit tag that'll be attached to that unit. They're also going to give you the order with their information, their vital statistics, what time they started it, what time they stopped it, all the signatures, things like that. So they want to make sure that you get all that information. And they're also going to bring you a post sample at the time. Oftentimes they're going to draw a red and a purple depending on your institution's policy. So you want to get that information all, get it set up on your bench. Then what you have to do is you have to go and find some other things. Look up the patient history. Find out the type of the cross match that was just done on this unit, when it was done, what it came up with, screen was negative, all that fun stuff. In our lab, you're going to look for the worksheet. Where was the workup done? Who did it? What steps along the way? You're going to find that original worksheet. You're going to go dig in the fridge. You're going to look for that pre-sample. Now remember, if you're in a busy lab, this could be 4 or 5 different racks of samples that you're going to have to look for that day and time. So, it may take you a little bit to find it. And then you're going to grab yourself transfusion reaction form in our lab. In the clinical setting, it's all going to be done electronically. In our lab, we're still doing paper, but that's what you're going to follow along the way as you're filling it out. First thing we're going to do, we're going to start with the basic workup. Basic workup, everybody gets done 99.9% of the time. This is as far as it's ever going to go because it's not going to be an antigen antibody, red cell antibody complex thing going on. It's going to be something else. But basic workup, first thing you're going to do, you're going to do the clerical check. When it comes to the patient, you're going to look for the sample, the unit tag, and the worksheet. I want you to look at the name and the medical record number on each of those. So you're going to look at the patient sample and you're going to write the name and you're going to write the medical record number. Then you're going to look at the unit tag, the name, write the name down, write the patient MR number. Then you're going to look at the worksheet, write the name, write the MR number. Then you're going to look at all three. Do they all three match? We do not just look at the sample, write it down, and copy it into the 3 columns. We want to look at each of those 3 sources and make sure all 3 sources actually match. Next thing we're going to do is we're going to look at the donor bag. Or the donor side of things. We're going to look at the donor bag, the unit tag, and again, the worksheet. So you're going to look, what did the unit number say? What did it say on the donor bag? What did it say on the unit tag? What did it say on the worksheet? Then you're going to look at all 3. Do they all 3 match? So that's the first part, clerical. We're going to make sure that the person that we thought was supposed to get the blood actually got the blood. And that we didn't misspell a patient name and it didn't go to a Joe Smith instead of a John Smith, or the medical record numbers weren't switched, or somebody thought there was a nickname of a patient, something along those lines. Next step we're going to do then is evidence of hemolysis. We're going to look at the unit. We're going to look at the post sample. Does anything look out of ordinary? Then we're also going to get the urine. So there's always going to be a urine collected post reaction. A lot of times, as we all know, that's not actually done in the blood bank, so you may have her over. If it's a small lab, hey Judy, what's the urine look like on this patient? Otherwise, you may have to pick up the phone and call. What's the urine look like? Is it yellow? Was there any blood seen in it? On the dipstick, macroscopically, microscopically, what are we looking at? Next step then, we're going to do the ABO-RH of the post sample and the DAT on the post sample, okay? The ABO-RH, we want to make sure it matches all the records. What if the post sample was an A, but our pre-sample was an O? We got a problem there, right? So we're going to do the post sample. Does it match still? And the DAT on the post, we're going to look for it. We're going to look for the IgG and the complement. What's going on? In our lab, we had those set up for you on the side, and we gave you the reactions of the macroscopics and the salines. So I wanted you to actually look at the microscopics of the poly, the IgG, and the complement. Once that is done, if everything here is negative, no clerical problems, no hemolysis, DAT was negative, ABO-RH looks good, everything looks good, we're going to call that pathologist. Now don't forget, at the very beginning, we called that pathologist too, right? We call them, we let them know, hey, this is going on, put them on the task of taking care of the other side of it. We're going to call them, we're going to give them all these results. Most of the time, we're good to go, we're stopping here, no problems. Once in a while, if any of these things are positive, we're going to have to go on to the extended, or once in a while our pathologist may say, my gut says something else is still going on, so can you continue on to the extended? Follow the pathologist, do what you need to do. When we're getting into the extended, we're going to go back to the pre-sample and the donor, and we're going to verify the ABO-RH. Now, you have all that information on that worksheet we went to look for. You have it on all the donor tags. You have it on all of it, but we just want to verify. So a second person is going to look at that, verify the ABO-RH on the pre and the donor. Then we're going to do the DAT on the pre. Now again, in our lab, I had a lot of that set up for you. But you're going to do a DAT on the pre. Because if the DAT is positive on the post, and then we do it again here on the pre, is it really going to be something significant? Maybe this person has an autoantibody, which is significant, but it's nothing specifically that the blood bank can do anything about, but it's important to know. Then we're going to do an antibody screen and a cross match on both the pre and the post. So I know we did this on the pre before, but now we're going to do it on the pre and post simultaneously. Now, all of this is in one little section, so like we always do in the lab, we do screens, start those because they have the incubation. And we want to make sure they're incubating them while you're doing that ABO and RH. But we're going to do the antibody screen and the cross match on the pre and the post. We're going to kind of look at all that, what's going on. If the DAT is positive on the post but negative on the pre, something likely happened during the transfusion. So now we need to figure out what's happening. So that's when we're going to do our acid elution. Now in our lab right now, we aren't actually doing that. We're doing the Martha Stewart version of it, but let's talk about what's going on with that. So with the elution, we get this working wash, which has kind of like a detergent in it to make sure we're getting all those free-floating antibodies and proteins and things off those cells. We are going to take donor cells. So this is our post sample. Okay, our post sample is going to be mostly patient cells with a handful of donor cells that are coated with the antibodies. Okay, so that's what we're looking for. When we're doing an elution, we're eluting off those antibodies. We're pulling them off. We're using acid to break that bond. And when we break that bond, the antibodies are going to elute off of the cells, and we can actually test for those antibodies then. So this is our sample. We got our donor mixed in with our patient. So we had 20 drops of acid. And the acid is going to go in and it's going to break those bonds, and we're going to centrifuge it down real hard. And then the supernatant is going to be our eluate. Then what it's going to be, it's going to have the antibodies. And we don't care about these cells anymore on the bottom. We really just are looking for what antibodies are coating those cells. So then we're going to take that supernatant off into another tube, and we're going to add 20 drops of buffer. When we're doing the buffer, we want to bring the pH back to 6.5 to 7. Now, if you remember, when we add the acid, it's going to break those bonds. If we leave this acidic and try to use the eluate against our 1, 2, and 3 cell, they're never going to bond. It's too acidic. It's not going to make those reactions so we can see them. So it's really important for us to bring it back to a more neutral pH, 6.5 to 7, in order to put it into those red cells and test it. So bring it up to the pH, and now it's going to be this like funky bluish, greenish, kind of funky color. And now this is our eluate. We're going to label that too, patient, first 3 letters of the last name, eluate, and now we're going to identify that antibody. So we do a special panel. So now we're down to this step here. On the panel, we're going to take the eluate and we're going to follow the special instructions in your lab manual. There are special instructions to using an eluate. One of the big instructions is you're going to put a drop of each of the cell in the tubes, and you're going to wash that cell one last time, just like our DATs, because we don't want that saline. We don't want anything diluting out our eluate because there's not going to be a ton of antibody likely in the eluate. So we're going to wash that cell down. The other special instruction is that it's going to take a little bit longer to incubate. It's a 20-minute incubation versus a 15 minutes. So make sure you're following your lab manual when you get to this, and you're not following the regular antibody ID. You're following the antibody ID using the acid eluate. So once you get that eluate set up in a panel, you're also going to set up the corresponding cell. So in our lab this week, it was an A cell. And then you're going to set up an auto control with the eluate to see what's going on. Then we're going to antigen type. Once we figure out what the antibody is, you may have to find select cells, things like that, just like we've always done with the antibody ID. Once you figure it out, we're going to antigen type. You're going to have a positive control and negative control. Then you have to antigen type the pre-sample. You cannot antigen type the post-sample because remember that post-sample has some donor and some patient, so the reaction isn't one population, it's a mix. So it's really important you go back to that pre-sample from before they got any blood, and now we're going to antigen type that. We're going to do a patient control, and we're going to antigen type the donor. So what we're looking for pretty much in this situation is we're looking for the donor that had an antigen on its red cells. Then when we gave the patient has an amniotic response, meaning what happened was at some point 20 years ago, let's say, they were exposed to anti-Big E when they got a couple units of blood. They developed the response, but over years, those antibodies fell off and we didn't really see them. That's why on that pre-antibody screen, we didn't see any antibodies. They were all negative. And on the post, maybe then we might see antibodies, maybe not, depending on how many of the antibodies are binding to those donor cells. But what we're looking for is we give the donor cells a second response, spike up an antibody. Remember that second response is going to be really, really fast, really, really big, and we're going to get that response, and now the patient's developing antibodies again, and now we're able to catch them to the E antigen that they had just gotten on their blood, in which case we expect to see positive E antigen on the donor, negative E antigen on the pre-sample antigen typing. Hope that explained things a little bit better for you. If you have any questions, please reach out to your instructor.